A radar speed gun is a device used to measure the speed of moving objects. It is used in law enforcement to measure the speed of moving vehicles and is often used in professional spectator sport, for things such as the measurement of bowling speeds in cricket, speed of pitched baseballs, athletes and tennis serves. A radar speed gun is a Doppler radar unit that may be handheld, vehicle-mounted or static. It measures the speed of the object at which it is pointed by detecting a change in frequency of the returned radar signal caused by Doppler effect, whereby the frequency of the return signal is increased in proportion to the object's speed of approach if the object is approaching, and lowered if the object is receding. Such devices are frequently used for speed limit enforcement, although more modern LIDAR speed gun instruments, which use pulsed laser light instead of radar, began to replace radar guns during the first decade of the 21st century, because of limitations associated with small radar systems. History: the radar speed gun was invented by John L. Barker Sr. and Ben Midlock, who developed radar for the military while working for the Automatic Signal Company in Newark, Connecticut during World War II. Originally, Automatic Signal was approached by Grumman Aircraft Corporation to solve the specific problem of terrestrial landing gear damage on the now legendary PBY Catalina amphibious aircraft. Barker and Midlock cobbled a Doppler radar unit from coffee cans soldered shut to make microwave resonators. The unit was installed at the end of the runway, and aimed directly upward to measure the sink rate of landing PBYs. After the war, Barker and Midlock tested radar on the Merritt Parkway. In 1947, the system was tested by the Connecticut State Police in Glastonbury, Connecticut, initially for traffic surveys and issuing warnings to drivers for excessive speed. Starting in February 1949, the state police began to issue speeding tickets based on the speed recorded by the radar device. In 1948, radar was also used in Garden City, New York. Mode of operation Doppler effect speed guns use Doppler radar to perform speed measurements. Radar speed guns, like other types of radar, consist of a radio transmitter and receiver. They send out a radio signal in a narrow beam, then receive the same signal back after it bounces off the target object. Due to a phenomenon called the Doppler effect, if the object is moving toward or away from the gun, the frequency of the reflected radio waves when they come back is different from the transmitted waves. From that difference, the radar speed gun can calculate the speed of the object from which the waves have been bounced. This speed is given by the following equation, where c is the speed of light, f is the emitted frequency of the radio waves and if is the difference in frequency between the radio waves that are emitted and those received back by the gun. This equation holds precisely only when object speeds are low compared to that of light, but in everyday situations, the velocity of an object is directly proportional to this difference in frequency. By rearranging terms we can see that if is proportional to the absolute frequency as well as the object velocity. Any change in f, the operating frequency in a radar gun, will produce a change in the calibrated relation between if and v. Stationary radar after the returning waves are received, a signal with a frequency equal to this difference is created by mixing the received radio signal with a little of the transmitted signal. Just as two different musical notes played together create a beat note at the difference in frequency between them, so these two radio signals are mixed to create a beat signal, and an electrical circuit then measures this frequency using a digital counter and displays the number on a digital display as the object's speed. Since this type of speed gun measures the difference in speed between a target and the gun itself, the gun must be stationary in order to give a correct reading. If a measurement is made from a moving car, it will give the difference in speed between the two vehicles, not the speed of the target relative to the road, so a different system has been designed to work from moving vehicles. Moving radar in so-called moving radar, a gun receives reflected signals from both the target vehicle and stationary background objects such as the road surface, nearby road signs, guardrails and streetlight poles. Instead of comparing the frequency of the signal reflected from the target with the transmitted signal, it compares the target signal with this background signal. The frequency difference between these two signals gives the true speed of the target vehicle. Design considerations modern radar speed guns normally operate at X, K, Ka, and Ku bands. Radar guns that operate using the X-band frequency range are becoming less common because they produce a strong and easily detectable beam. Also, most automatic doors utilize radio waves in the X-band range and can possibly affect the readings of police radar. As a result, K-band and Ka-band are most commonly used by police agencies. Some motorists install radar detectors which can alert them to the presence of a speed trap ahead, and the microwave signals from radar may also change the quality of reception of AM and FM radio signals when tuned to a weak station. For these reasons, handheld radar typically includes an on-off trigger and the radar is only turned on when the operator is about to make a measurement. Radar detectors are illegal in some areas. Limitations. Traffic radar comes in many models. Handheld units are mostly battery-powered, and for the most part are used as stationary speed enforcement tools. Stationary radar can be mounted in police vehicles and may have one or two antennae. Moving radar is employed, as the name implies, when a police vehicle is in motion and can be very sophisticated, able to track vehicles approaching and receding, both in front of and behind the patrol vehicle. It can also track the fastest vehicle in the selected radar beam, front or rear. However, there are a number of limitations to the use of radar speed guns. For example, user training and certification are required so that a radar operator can use the equipment effectively. Stationary traffic enforcement radar must occupy a location above or to the side of the road, so the user must understand trigonometry to guess vehicle speed as the direction changes while a single vehicle moves within the field of view. Vehicle speed and radar measurement are rarely the same for this reason. Radar speed guns do not work reliably in traffic, and significant vehicle separation is essential for proper operation when used for speed monitoring. Mobile or handheld radar is only reliable when one moving object is in the field of view and there are no other moving objects nearby. Size. The primary limitation of handheld and mobile radar devices is size. An antenna diameter of less than several feet limits directionality, which can only partly be compensated for by increasing the frequency of the wave. Size limitations can cause handheld and mobile radar devices to produce measurements from multiple objects within the field of view of the user. The antenna on some of the most common handheld devices is only 2 inches in diameter. The beam of energy produced by an antenna of this size using X-band frequencies occupies a cone that extends about 22 degrees surrounding the line of sight, 44 degrees in total width. This beam is called the main lobe. There is also a side lobe extending from 22 to 66 degrees away from the line of sight, and other lobes as well, but side lobes are about 20 times less sensitive than the main lobe, although they will detect moving objects close by. The primary field of view is about 130 degrees wide. K-band reduces this field of view to about 65 degrees by increasing the frequency of the wave. Ka-band reduces this further to about 40 degrees. Side lobe detections can be eliminated using side lobe blanking, which narrows the field of view, but the additional antennas and complex circuitry impose price constraints that limit this to applications for the military, air traffic control, and weather agencies. Mobile weather radar is mounted on semi-trailer trucks in order to narrow the beam. In comparison, the human eye can see accurately within a small region about 5 degrees wide. The FOV determines the direction in which a person is looking, which is called the visual line of sight. Accurate vision extends about 20 degrees. Our total field of view is about 100 degrees horizontally and 60 degrees vertically. Thus, the field of view for small handheld and mobile radar devices may exceed the visual field of the user because of side lobe detections. Distance. A second limitation for handheld devices is that they have to use continuous wave radar to make them light enough to be mobile. Speed measurements are only reliable when the distance at which a specific measurement has been recorded is known. Distance measurements require pulsed operational cameras when more than one moving object is within the field of view. Continuous wave radar may be aimed directly at a vehicle 100 yards away but produce a speed measurement from a second vehicle 1 mile away when pointed down a straight roadway. Operators cannot be certain which object's speed the device has measured without distance information, which is unavailable with continuous wave radar. Some sophisticated devices may produce two different speed measurements from two objects within the field of view. This is used to allow the speed gun to be used from a moving vehicle, where a moving and a stationary object must be targeted simultaneously, but reliable operation cannot be achieved when more moving objects are added to the environment. Portable handheld or vehicle-mounted radar cannot produce reliable measurements when more than one moving vehicle occupies the field of view. Environment equals, the environment and locality in which a measurement is taken can also play a role. Using a handheld radar to scan traffic on an empty road while standing in the shade of a large tree, for example, might risk detecting the motion of the leaves and branches if the wind is blowing hard. There may be an unnoticed airplane overhead, particularly if there is an airport nearby. Handheld radar is only reliable on single vehicles when the location has been certified to be free of environmental influences that will cause false readings. Site survey must be repeated periodically for reliable operation. Associated cameras. Conventional radar gun limitations can be corrected with a camera aimed along the line of sight. Cameras are associated with automated ticketing machines where the radar is used to trigger a camera. The radar speed threshold is set at or above the maximum legal vehicle speed. The radar triggers the camera to take several pictures when a nearby object exceeds their speed. 2 pictures are required to determine vehicle speed using roadway survey markings. This can be reliable for traffic in city environments when multiple moving objects are within the field of view. It is the camera, however, and its timing information, in this case, that determines the speed of an individual vehicle, the radar gun simply alerting the camera to start recording. Newer instruments, laser devices, such as a LIDAR, a speed gun, are capable of producing reliable range and speed measurements in typical urban and suburban traffic environments without the site survey limitation and cameras. This is reliable in city traffic because LIDAR has directionality similar to a typical firearm because the beam is shaped more like a pencil that produces measurement only from the object it has been aimed at. See also, LIDAR detector, radar detector. Notes. External links. Hyperphysics, technical info and calculators for police radar, calibration of speed enforcement down the road radars.